This video covers measurement and density, so you may wish to have a calculator in addition to your notes and something to write with. So measurement is something that we do frequently in our lives, but we maybe haven't thought very deeply about how we report things that we measure. And so when we're talking about a measured quantity, we're talking about something, some specific amount of something, and that always consists of a number and a unit. So the number will tell us how many or how much, and the unit tells us the scale of measurement. So if you are measuring length, then you would need to include the number and the unit, because you could have a number of different units that you use for length. So 5.2 kilometers, so that's we're going to run a 5K. Say you're going to run a 5K, so you're going to run 5.2 kilometers. You would never say to somebody, I'm going to run 5. 5 what? 5 minutes, 5 miles, 5 kilometers, 5 centimeters. So we always have to include both the number and the unit. It's very critical for clarity. And we can use a number of different devices. So in lab, we will be using an analytical balance as well as a graduated cylinder. We could also measure and pour things with a measuring cup or a beaker. We've probably all used rulers at some point. So you have to know what you're trying to actually measure and what unit you want so that you can use the appropriate equipment as well. So the SI system of units is an international system, and this was established so that scientists could effectively communicate with each other. And so we also call this the metric system. And in the United States and Liberia and Myanmar, we pretty much just use imperial units. The UK is a real mix of imperial units. And then we have a mostly metric around the rest of the world. And it's really critical that we do these types of conversions correctly between imperial and metric, because there have been some very expensive mistakes made when we don't keep track of units and lose sight of these conversions. So for example, a couple of the NASA projects that were worth billions of dollars were lost because of mistakes made in conversions. So we are going to talk mostly about some simple units, the fundamental units in the SI system, and honestly, there aren't that many of them. And most of these units that we use are actually derived units. So we'll talk about that in a minute, but I want to talk about the property and then the unit that we use. So the property of length is always the meter. The mass, it's always the kilogram, and the time is the second. We'll talk more about mole and Kelvin later. Volume is technically a derived unit, so it comes from the amount of space that certain amount of matter takes up. So we will be talking about volume and density here, which are both derived units. But we really just want to make sure that we know which unit we're going to use for which property. So if it's length, it's meter. Mass, it's kilogram. And then if you're going to use a different prefix, that's okay. We will talk more about that next week. So density is our derived unit, and they are combinations of SI-based units. And so units can be multiplied and divided just like numbers can be multiplied and divided. So density is the mass of an object divided by its volume. So the unit for density is mass over volume. This is the unit. So even though it looks like it's 2 units, it's not. This unit of density is mass over volume. We don't have like a specific word for it. Volume is a derived unit as well. And you can get the volume of something out of a cube by multiplying its length times its width times its height. And so that volume, sometimes we have a word for that, and that would be the liter. And so it can be a little bit confusing sometimes if you're not used to thinking about a unit as something that you can multiply and divide the same way you do a number. But we can do that, and we want to make sure that we're paying attention to all of our units and writing them down all the time. So we're going to do a couple of examples. Feel free to attempt them on your own and then play the video if you would like. So here's an example where we have 20 milliliters of liquid, and it's poured into an empty beaker, which is just a special lab container. And that beaker has a given mass of 31.447 grams. And so we measure out 20 mils, pour it into this beaker, and now we have a total mass here, and we want to know the density of the liquid. So the information that we have is the mass of the beaker and the liquid, and the volume of the liquid, but we don't know the mass of the liquid yet. So that's our step one, is to calculate the mass of the liquid. And we will do that by taking the combined mass of the beaker and the liquid together and subtracting the mass of the beaker. And we get 24.444 grams. And so that is the mass of our liquid. And now we're ready to calculate the density. So we take our mass and divide by our volume, and we can get our density, which is 24.444 grams divided by 20 milliliters. So that gives us a density of 1.222 grams per. Okay, here's another example, and I like this one because it demonstrates how volume is technically a derived unit. So here's just a reminder, this is our density formula, and we'll be using this for part 2 of the problem. But we have a rectangular object, and it measures 4 centimeters by 3 centimeters by 2. And so we can get the volume of this object by multiplying these 3 measurements together, by these 3 quantities together. And we can't just multiply the numbers, we have to multiply the units too. And so if we do that, 4 centimeters times 3 centimeters times 2 centimeters, what that's going to give us is 24 centimeters cubed, because we're multiplying centimeters by itself 3 times. So centimeters cubed. And it turns out that 1 milliliter is the same as a centimeter cubed. And so we will often use the liter or milliliter for volume, even though technically it would be a derived unit in this case, right? So we took the information about our object and calculated the volume. Now we have the density of the object, and it is 0.35 grams per centimeter cubed. So for every centimeter cubed, it's 0.35 grams. So what is the mass of the object? Well, we're going to use our density equation here. And so we have our 0.35 grams per centimeters cubed, and that's going to equal the mass divided by the volume. We know the volume, we don't know the mass. So this mass here is our unknown. So we have to solve for this value right here. And the way we're going to do that, so we're going to multiply both sides of the equation by this quantity here. And that way we isolate our mass, and we take 0.35 grams per centimeter cubed, and we multiply that by 24 centimeters cubed. Notice how our units here will cancel out, and we are left with 8.4 grams. And so that is how we work with these measured quantities.